All right, ladies and gentlemen, let's get the next session underway. Our first speaker of this session is Trey Hunter. Trey is a Python Django teacher, trainer, and mentor. He's a director of the Python Software Foundation, a member of the Django Software Foundation, and is heavily involved with his local Python meetup group in San Diego. Trey holds corporate training sessions on Python and Django by day, hosts live online teaching sessions for Python learners during nights and weekends by night, I'm guessing.
Yep.
And is otherwise just an all-round nice guy. So everyone, please welcome Trey Hunter.
Thanks, Tucker. So I'd like to go on a journey with you all through the land of iterables and iterators. This is pretty much everything Russell just said. So my name is Trey. I help Django teams turn their front-end developers into full-stack Django developers. I also host a live webcast every week on Python-related topics. Unfortunately, I do usually host it at what I think is typically 3 in the morning, Australia Eastern Standard Time. So you can watch the recordings online. I'm also one of the co-organizers of my local Python study group. I've helped organize 4 Django Girls workshops in Southern California, and I'm one of the 13 directors of the Python Software Foundation currently. All right, so that's a bit about me. Let's talk about looping, specifically looping problems. So every interesting journey starts with a problem. So we're going to look at some confusing things to kind of pique our curiosity, to hopefully motivate us to learn some things about how looping works under the hood in Python. So numbers here is a list. Squares is a generator. This generator will give us squares of each of the numbers in this list. Generators are lazy. We can't do much with squares except for loop over it. We could pass it to the tuple constructor here to make a tuple out of it. We could also pass it to the sum function to add up all of the squares of these numbers. Now, you might expect that we get a large number here. We get 0 instead. That generator was empty by the time we looped over it a second time there. So we're going to talk about what's going on there. We're also going to talk about what's going on here. So when we ask 9 in squares, what are we going to get? True. When we ask 9 in squares again, Python decides at this point it's false. 9 is not in squares. We ask the same question 2 times of this object, we get a different answer. We'll talk about what's going on here as well. This dictionary has 2 key value pairs. If we try to unpack this dictionary, you might expect that we get an error, or you might expect that we get maybe key value pairs, tuples of key value pairs, or maybe keys and values. If you're new to Python, there's a lot of different answers you could possibly come up with here. This does work. We do not get an error. You can unpack dictionaries. If you were expecting to get key value pairs, maybe tuples, you would be wrong. We don't get key value pairs of tuples. We get keys. When you unpack a dictionary, you get keys. This is a strange thing to do, but it does work. We're going to see what is going on here as well. So by the end of this talk, we're going to recap these 3 things here, and we'll hopefully already have answers to these because of what we've learned. All right, so before we dive in, let's review a few things to make sure we're all on the same page. We're going to review loops, iterables, and sequences to make sure that we all understand how they work in Python. This is not Python. This is JavaScript. This is a traditional C-style for loop written in JavaScript. In this for loop, we set I to 0. We check whether I is less than the length of an array, which is basically like a list in Python. And we increment I by 1 each time as we loop. Once this condition is no longer true, we'll stop looping. So we end up printing out all of the numbers in this array. This is a for loop. Python does not have for loops. Python does not have traditional C-style for loops, at least, like we see here. What we do have in Python is a for-in loop. Our for-in loop is the same as what many programming languages call a for-each loop. If you look up for-each on Wikipedia, you'll find this loop. We tend to call our for-in loops just for loops because they are the closest thing that we have to traditional C-style for loops. They are not the same, though. They're very different. So I'll be calling these for loops during this talk because for-in loop is something no one ever says in the Python world. So in this for loop, we're doing the same thing as before. We're looping over these items. Notice we don't have an index variable. We're not incrementing anything. We don't have any indexing at all. Python does all of the work of looping for us, whereas before we were manually looping using an index. So Python doesn't have traditional C-style for loops. We do have something we call a for loop. It is different, though. All right, if you can loop over something with one of these for loops in Python, it is an iterable. And if something is an iterable, you can loop over it with a for loop in Python. So if you're unsure what that word iterable means, if you've heard it before, you're not sure of the definition, that's what it means. It means anything that you can iterate over, that is an iterable. Iterables can be looped over, and anything that can be looped over is an iterable. Sequences are a very common type of iterable in Python. Lists are sequences, tuples are sequences, and strings are sequences. Sequences are iterables which can be indexed starting from 0 and ending at 1 less than the length of the sequence. Lists, tuples, and strings, and all of the types of sequences can be indexed in this way. They have other features, they have lengths and slicing, but I'm not going to talk about those things. I want you to know that while lots of things in Python are iterables and lots of things are sequences, many things in Python are iterables but not sequences. Sets are iterables. Dictionaries are iterables. Files are iterables. And generators are iterables. We even have infinitely long iterables. So count in the itertools module, this is an infinitely long iterable. None of these things here are sequences. They are all iterables, though. We can loop over them. All right, so this is what we know. We know that Python doesn't have traditional for loops. We do have something that we call a for loop. And anything that you can loop over with a for loop is an iterable. Sequences are just one type of iterable, but we have many other types of iterables in Python. So we're done with review at this point. Let's talk about how for loops work in Python. Specifically, let's talk about how we could loop over an iterable without using a for loop. I'm going to pause at this point. Who's using Python 2 primarily in your code? All right, who's using Python 3 primarily in your code? Wow, OK, that is different than it would have been a few years ago. For those of you using Python 2, there are a couple slides in this presentation that are Python 3 specific, so good luck finding those. The next one is not one of those slides. So we're going to talk about how loops work, and we're going to try to re-implement a loop without using, or re-implement a for loop without using a for loop. This is possible, but we can't use indexes for it. So if we try to set I equal to 0, and there's a bug in this code. I'm supposed to have an I plus equals 1 here. Imagine there's an I plus equals 1 at the end of this slide. This works for lists. This would work for lists if there was an I plus equals 1. This does not work for any other type of iterable outside of sequences. Sequences are the only thing this works for, lists included. Sets, which remember are not sequences, this doesn't work for. If we try this same thing, we get an error. Sets cannot be indexed. So at this point, we could try converting this set to a list, looping over it that way. That would be cheating, first of all. Also, that doesn't work for infinitely long iterables. If you convert an infinitely long iterable to a list, you will fill up your RAM and you'll be unhappy. So for loops in Python are not powered by indexes. They are powered by iterators. Iterators are the secret to looping in Python. Every iterable in Python can give you an iterator, and you can use that iterator to loop over your iterable. We have 3 iterables here. Again, a list, a tuple, and a string. We can ask each of these for an iterator using Python's built-in iter function. Passing an iterable to the iter function will always give us back an iterator, no matter what type of iterable it is. Lists, strings, and tuples are all iterables, and every iterable will provide us with an iterator if we use the built-in iter function in Python. OK, so we can get iterators. What's the point of these, though? Once we have an iterator from an iterable, the only thing that we can do with it is get the next item from it. That is the one thing that we can do with an iterator. We can use Python's built-in next function to get the next item from any iterator. And if you ask for the next item and there are no more next items, you'll get a stop iteration exception. This is the only thing you can do with iterators in Python. So you can think of iterators as kind of like one-directional tally counters with a broken reset button. They keep track of where you are when you ask them for their next item, but they can only go in one direction, and they cannot be reset. Once you're done with the tally counter, you have to throw it out. So iterators are one-directional tally counters without a reset button. If you would like, you could also think of iterators as like Hello Kitty pest dispensers. except that they cannot be reloaded. So iterators are like Hello Kitty Pez dispensers, except that once that they're empty, all of the Pez are gone, you have to throw them out, you have to discard them. You cannot reload or loop back iterators. All right, so now that we know what iterators are, let's take a look at this loop, this for loop, and turn it into a while loop. So we have a for loop here. This is how we normally loop in Python. We can manually implement this ourselves. So memorize this for loop for a moment. We've got a function, we've got an iterable coming in, an action we're doing every time as we loop. This same thing, this code's going to get a little bit bigger, is this. In order to manually loop over an iterable, we need to get an iterator from it, and then repeatedly loop, and get the next item each time that we loop, or asking that iterator for the next item as we loop. And then once we have that item, we can do whatever the body of our loop was. In this case, it was just one line of code. While we're getting that next item, if we get a stop iteration exception, we know that we're done looping at that point. We've just reinvented a for loop by using a while loop and what we've learned about iterators here. This is how all looping works under the hood in Python, all of it. So these facts that we've just learned about iterators, this is part of a fancy-sounding thing called the iterator protocol. This is the thing that powers all iteration in Python. So iterators power all iteration. It's called the iterator protocol. For loops rely on iterators in the iterator protocol. Tuple unpacking does this under the hood as well. Works the same way as a for loop. Star expressions also rely on the iterator protocol. Many built-in functions, many third-party library functions, many standard library functions rely on the iterator protocol. Anything that may have some form of looping uses this form of looping. They all rely on iterators in Python. So the iterator protocol powers all forms of iteration in Python. All right, so at this point, you might think iterators seem cool, but they also just seem like an implementation detail. Why should we as Python programmers care about this? You know, most of us in this room are not core developers. We are simply users of Python. So why should we care about these iterator things? So I have some news for you. You have seen iterators before. In fact, we've already seen some iterators before I mentioned the word iterator on my slides here. This is a generator. This generator object is also an iterator, which means that we can pass it to the next function. Any iterator can be passed to the next function to get its next item. So generators are iterators. There is something else that you can do with generators, though. What's the other thing that you can do with generators? You can loop over them. What does it mean if you can loop over something? What type of thing is that? An iterable. So I've just said that generators are iterators, but you know that generators are iterables. So are generators iterators or iterables? What's going on here? So I haven't been telling you the truth, or at least I haven't been telling you the whole truth here. There is something very important that I forgot to mention about the iterator protocol. Iterators are also iterables. All iterators are iterables. What that means is that you can get an iterator from an iterator using the built-in iter function in Python, just like we can with any other iterable. So we can call iter on an iterator to ask it for an iterator. And when we do that, it will always give us itself back. Iterators are iterables, and their iterator is themselves. Iterators are their own iterables. So at this point, this is kind of confusing. We've got the word iterator. We've got the word iterable. You can think of iterables as something that you are able to iterate over. An iterator is the thing that does the iteration. It just so happens an iterator is also an iterable, though. So this fact that I've neglected to mention, this is the last part of the iterator protocol. This is the final part of the iterator protocol, which I don't actually have fully on a slide here, but you can look it up yourself. If you ask an iterable for an iterator and it gives you itself back, it must be an iterator. The opposite is true as well. If an iterator always will give you itself back when you ask it for an iterator. All iterators are iterables. and all iterators are their own iterator. So iterators are iterables, but they have no idea how many items they contain, unlike some types of iterables. They also can't be indexed. The only thing that we can reliably do with iterators is get the next item on them and loop over them. Those are the only two things that you can do with iterators. And if we loop over an iterator a second time, we'll get nothing back. They're exhausted at this point. Iterators are lazy iterables. They can only be looped over once and then they're done. So iterables are not necessarily iterators, but iterators are always iterables. For example, generators are iterators, but lists are not iterators. Iterables are not always iterators, but iterators are always iterables. Who's not confused at this point? All right, a few of you. I'm surprised, I'm confused. So let's talk about why we should care about these iterator things. We tried to talk about why we should care about these, and then we learned that generators are iterators and got distracted here. Let's go back to that. Here are a few reasons you should care about iterators. Iterators allow us to work with and create lazy iterables. Anytime you want something to happen lazily, you could use an iterator. Iterators also allow us to make infinitely long iterables. The iterator protocol is very, very simple. The simplicity of it is a problem for us occasionally, but it's also a huge benefit in Python for us as iterable implementers and iterable users. The simplicity of the iterator protocol is the reason we have a plethora of different types of iterables. There are many different types of iterables because they all rely on something very simple under the hood, the iterator protocol. The iterators are foundational to all looping in Python. All looping relies on iterators. Okay, so we've seen lots of iterators, or you've already seen lots of iterators in Python, and I've mentioned that generators are iterators. Enumerate objects are also iterators. Zip objects are iterators as well. Reversed objects are iterators. And files are iterators. There are lots of types of iterators, both in the standard library, in third-party libraries, and built straight into Python. Django query sets are not iterators. They are sort of lazy, though. Django query sets will not query your database until you ask them for an iterator. Only at that point will they do a database query. Will a database query get executed? So Django query sets won't do any work until you start to loop over them. And they cache their results so you don't need to do the same query more than once. But they are not iterators. Kind of lazy, not iterators. So the fact that Django query sets cache their results is useful, but it can be problematic. If you're looping over 1,000,000 rows, you may not necessarily want all of those 1,000,000 rows cached in memory at once. That may be a bad idea. So if you don't want 1,000,000 rows in memory, there is a way to avoid Django's typical caching with query sets. You can use the iterator method on query sets. The iterator method does not give us back a query set. It gives us an iterator object. And just like every other iterator, we can call the next function on it to loop over it once, or we can loop over it all the way using list or a for loop or any other looping construct we'd like. So once we've looped over this query set iterator, it is consumed, just like every other iterator. So it doesn't cache things. We don't get the other benefits of query sets, but it is lazy. If you need something lazy, you want Django's query set iterators. Note that this is more memory efficient. This is not caching anything under the hood. And at the database level, it's actually doing something a little bit fancy that I'm not going to talk about that involves getting these items in an efficient way one by one. Okay, so you cannot just use iterators, generators, enumerate, zip, Django's iterators. There are many types of iterators out there you can use. You can also make your own. So if you need to make a lazy iterable, you should think of iterators. This here is an iterator class. This class makes an iterator that accepts an iterable of numbers, and it squares each of those numbers. If this iterator was passed an infinitely long iterable or a very long iterable, it will lazily square them. So it only squares them when we ask it for its next item. This works, but you don't usually create iterators this way. This is not the typical way we make iterators. Usually when we want to make an iterator, we make a generator function, because generators are iterators. This generator function is equivalent to that class. Now, if you haven't seen generator functions before, that yield statement might seem magical. It is a little bit magical. It's not a return statement, it's its own thing, but it is very powerful. That is the thing that allows us to put our generator on pause in between next calls. Another way we could implement this same thing is with a generator expression. This is equivalent to that generator function, which is equivalent to that iterator class. This does the same thing. Its syntax looks more like a list comprehension, though. So if you need to make a lazy iterable, think of iterators and reach for generator functions or generator expressions. Once you've embraced the idea of these lazy iterables, regardless of whether you're making your own functions or using someone else's, you will discover that there are lots of possibilities for writing your code in a very different way, turning kind of your code on its head or inside out to write your code in a different fashion than what you could have before. This is a for loop. This for loop loops over a Django query set, let's say, and it sums up all of the billable hours in this query set. This is the same code, but it's using a generator expression to lazily evaluate or lazily loop over that query set. So these two blocks of code do the same thing. They're written in a very different way, though. That first one is incrementing. We have to kind of keep track of a variable there. That second one, we're able to use the sum function because the sum function accepts an iterable. We happen to have a lazy iterable, but it is an iterable. This code prints out the first 10 lines of a log file. Notice we have an early break here. This code does the same thing. We're using a helper function, though, a helper function that's built into the standard library, to grab just the first 10 lines off of this log file, because we know that this log file is an iterator, and iterators can be, we can use the islice function to work with iterators and grab those first 10 lines. So notice we were able to name something here that we could not possibly name before. We've named first 10 lines. Naming a variable is an important thing to do. If you have something important in your code, you should give it a name. We couldn't give it a name in the first case because there's no variable we could possibly store there that would make sense to loop over, at least not a lazy one. So by the way, the itertools library, if you haven't looked into it, definitely make sure you look up and explore it. It has a bunch of helper methods for working with iterables and lazy iterators, or lazy iterables in general. This code makes a list of differences between consecutive values in a sequence. Notice that we've kind of got an extra variable that's running alongside our code here, that previous variable that we have to update every time. This code does the same thing. Does the same thing using a function that doesn't actually exist. I just made it up. You'll have to believe me that it works. But it gives us those two values at once. We no longer have something running alongside our code. There's no awkward variable assignment hanging around outside of our loop and inside of our loop. So this generator function here with previous allows us to write our code in a fundamentally different way. Once you've embraced the notion of lazy iteration in Python and iterables, or these lazy iterators, you can write your code in a different fashion. So that generator function, if you're curious what it looks like, this is one possible implementation of it. Notice that we're actually relying very heavily on the iterator protocol here. We're manually grabbing an iterator from an iterable. We're calling next on it to grab its first item, and then we're looping over it to get the rest of the items. This works for any iterable. Before, it only worked for sequences because we were slicing, and you cannot slice iterators. All right, at this point, we're ready to jump back to those odd examples that we saw earlier and figure out what's going on. So here we have a generator object, like we had before, squares. If we pass this generator to the tuple constructor, we'll get a tuple of its items back. If we then compute the sum of these numbers, as we've already seen, we get 0. The reason we get 0 is that this generator is empty. We've exhausted this generator. If we try to make a tuple out of it again, we get nothing back. So this lazy iterable we saw before, this generator, it was an iterator. It's been exhausted at this point. Generators are iterators, and iterators are like Hello Kitty Pez dispensers that have to be thrown out because they can't be reloaded. Once we run out of Pez, our Pez are gone forever. If we ask whether 9 is in this squares generator, we'll get true. If we ask the same question again, as we already saw, we'll get false. The reason this happened is when we asked 9 in squares, this question created or caused Python to loop over our generator. And when we looped over our generator, we had to partially evaluate it. So the only numbers left in this squares generator, if we made a list out of it, were all the numbers after 9, 25 and 49. Iterators are like one-directional tally counters with a broken reset button. There is no way to know whether something is in an iterator without starting to loop over it. When you loop over dictionaries, you get keys. Looping relies on the iterator protocol. Iterable unpacking also relies on the iterator protocol. So you get the same thing. You get keys. At this point, this shouldn't be surprising. This might have been surprising before. This isn't surprising now because we know that all forms of iteration are the same in Python. Both of these rely on the iterator protocol. Iterators are the most rudimentary form of iterables. When working with iterables, try to assume that you are working with iterators, or it's possible that you're working with iterators, because you very well might be working with iterators sometimes. Iterables cannot necessarily be indexed. Sequences can be indexed. Not all iterables are sequences. Iterables do not necessarily have a length. You can't make assumptions about your iterables except for one assumption. The only assumption you can make about your iterables is that you can iterate over them. That's it. So try not to assume that your iterables have more features than just iteration. And if you need to make your own lazy iterables, think of iterators, and more importantly, think of generators and think of generator expressions. And remember that if the operation that you're going to do may be using looping or iteration under the hood, the iterator protocol is being used, and iterators have to get involved. And there may be consequences to that fact. Okay, so if you write down one thing now, I would like you to write down generators. If you write down a second thing now, you should write down itertools. You probably don't need to write down any more things, but that's all I've got for you.